Assalamualaikum warahmatullahi wabarakatuh. My name is Syafiq Haikal bin Mukhtar. Today I will explain a interesting topic about set and universal set. What the set actually means? Okay, I explain first by step. Okay, the definition of a set is any collection of objects specific in such a way we can determine whether a given object or not in the collection. Okay, you get that? Okay, easily to understand, is a set is any collection, but in other words, a set is collection of objects. These objects are called element or member of the set. Let's look for example by set. First step, I draw the circle or elements of object. Okay, for I put a number or object 1, 2, 3, 4, 5. So this circle is a Venn diagram. Okay, so A equal to 1, 2, 3, 4, 5. Okay. So next, as we mentioned above, a set is a collection of listed objects. Calling element of the set, we usually use a capital letter to name a set and verses to enclose the element of a set. For instance, A equal to 1, 3, 5, 7. You can see two braces. Okay, that the set is consistent of the 4 elements 1, 3, 5, and 7. Okay, next we will rather describe the element of then list all their individual member. We can instead use it will national and write for above set. Okay, for example, as A equal to n a positive or integer. You can see behind me you can see or integer less than 7. Okay, so that's mean A is the set of all n such that is a positive or integer 7 less than 7. Okay, so let's look universal set. Okay, universal set, there are two types of set. Okay, so let's look at the first one, finite set. Okay, finite set just means a set which contains only finitely many elements. For example, the set of all tables in the classroom. We can see all tables in the classroom is a finite set. Okay? So let's P equal to 5, 10, 15, 20, 25, and 30. Then then we can see P is a finite set and P equal to C. Okay? So next, infinite set. A set which contain infinite elements. Okay. So for example, the set of all natural number. So W equal to 0, 1, 2, 3. Okay, and this is case we can see set of all whole number is infinite set. Okay, that's all from me. I hope can be clear about set and universal set. Thank you.
Thank you, Syafiq. Now we move to the second part. I'm Siti Mujahidah binti Hasan will explain about truth table. Okay, what is truth table? Truth table is a diagram in row and column showing how to the truth or falsity of a proposition varies with that of its component. T in the table stands for the true statement, while F stands for the false statement. If the compound statement has two variables, let's say P and Q, then the truth table must be constructed with 4 rows. It can be simplified into the formula given, 2 to the power of n, where n is the number of variables. Negation. Let P be a proposition. The statement, "It is not the case of P," is another proposition called the negation of P, denoted by negation P. Let's see the truth table for negation. When P is true, negation P will be false. We just inverse the truth value of P. So, when P is false, the negation of P will be true. Let's see the example in English statement. P, she is sick. Negation P, she is not sick. Conjunction. Let P and Q be proposition. The proposition P and Q denoted by P and Q is proposition that is true when both P and Q are true, then false otherwise. P and Q is called conjunction of P and Q. Let's see the truth table for conjunction. When P is true and Q is true, so P and Q will be true. When P is true, Q is false, and P is false, Q is true, and P is false and Q is false, P and Q will be false. Let's see the example in English statement form. P is raining, Q is cold. So P and Q, it is raining and cold. This junction, let P and Q be proposition. The proposition P or Q denoted by P or Q is the proposition that is false when both P and Q are false and true otherwise. P or Q is called the disjunction of P and Q. Let's see the truth table for this junction. When P is true and Q is true, and P is true, Q is false, and P is false and Q is true, the reason P or Q will be true and otherwise will be false. Let's see the example in English form statement. P, Amin ate durian yesterday. Q, Hafiz ate durian yesterday. So, P or Q will be Amin or Hafiz ate durian yesterday. Implications. Let P and Q be proposition. The implication P implies Q is the proposition that is false when P is true and Q is false, then true otherwise. P is called hypothesis and Q is called conclusion. Let's see the truth table for implication. As we can see, when P is true and Q is false, the result P implies Q will be false and the others Y will be true. Let's see the example of English statement. P, she is happy. Q, she wins some money. P implies Q, she wins some money when she is happy. By conditional, let P and Q be proposition. The by conditional statement, P if and only if Q is the proposition that is true when P and Q have the same truth value and false otherwise. Let's see the truth table for by conditional. When P is false and Q is false, P if and only if will be false and the otherwise will be true. Now let's see the example of English statement. P, she brings an umbrella. Q, it is raining. So P if and only if Q, she bring an umbrella if and only if it is raining. Okay, example 1. Using the truth table, show that P if and only if Q is logically equivalent. P implies Q and Q implies P. From the equation, we know that they have two variables. So we need to construct a truth table for 4 row because 2 to the power of 2 is 4, right? We construct P and Q as usual. For P implies Q, we know that proposition is only false when P is true and Q is false. So we get true, false, true, false. Same goes to Q implies P. The proposition will only false when Q is true and P is false, and the otherwise will be true. So we get true, true, false, true. So for P, if and only if Q, as I had early explained before, the proposition is true when P and Q have the same truth value and false otherwise. So we get true, false, false, true. So the last column, P implies Q and Q implies P. As I already explained before, the proposition is true when both P implies Q and Q implies P are true. Then the otherwise will get false. So we will get true, false, false, true. So as we can observe from the truth table, P, if and only if Q is logically equivalent to P implies Q and Q implies P because they have same proposition. Example 2. Using the truth table, determine the validity of argument. So, premise 1, P implies Q, premise 2, R and P, premise 3, negation Q, and the conclusion is P. So, as we know, it has 3 variables, so we need to construct a truth table with 8 rows because 2 to the power of 3 is 8. We construct PQR as usual. So for negation Q is just inverse of Q. So we get false, false, true, true, false, false, and true, true. For P implies Q, as I had explained earlier, the proposition is only false when P is true and Q is false. Then it will be true otherwise. So we get true, true, false, false, true, 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 true. Next, for R and P, the proposition is true when both R and P are true. Then false for otherwise. So we get true, false, 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 false. Next, for P implies Q and R and P, as I already explained, the truth value will only be true when both are true. Then all false otherwise. So we get true, false, 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 and false, false. For P implies Q and R and P and negation Q, will get all false. Then the last column, P implies Q and R and P and negation Q implies P, will get all true. Since the last column is all true, that means it is the tautology. So the argument is valid. That's all from my part.
Next, I will explain about arguments. Definition of arguments. Argument is a list of given statements called premises followed by the final statement called conclusion of the argument. An argument is said to be valid if whenever each of the premises is true, then the conclusion is also true. One way to prove validity of an argument is by showing that the implication is a tautology. The premises from the hypothesis of the argument and conclusion can be expressed as P1, P2, Pn, and Q. P1, P2, and Pn are hypotheses, and Q is the conclusion. The hypothesis consists of a list of one or more propositions or premises. Next is rules of inference. Truth tables are not practical to determine validity of arguments involving more than 3 propositions because the number of rows increases. In order to avoid large truth tables, a list of techniques called the rules of inference was developed. Each rule of inference arises from a logical implication. A few examples for rules of inference are modus ponens, law of syllogism, modus tollens, rule of conjunction, rule of disjunctive syllogism, and a lot more. Here is the first example. If Damia has enough savings, then she will buy a car. She is healthy or she has enough savings. She is not healthy, therefore she will buy a car. From this, we can separate it to 3 premises and a conclusion. First premise, if Damia has enough savings, then she will buy a car. Second, she is healthy or she has enough savings. Third, she is not healthy and the conclusion is, therefore, she will buy a car. From this, we can assume P is Damia has enough savings, Q is she will buy a car, and R is she is not healthy. We can make arguments by using the premises and the conclusion. P to Q, R or P, not R, and we can get the conclusion Q. The second example, Azman is playing badminton. If Azman is playing badminton, then he is not studying. If Azman is not studying, then his mother is angry. Therefore, Azman's mother is angry. From this, we can separate it to 3 premises and a conclusion. First premise, Azman is playing badminton. Second, if Azman is playing badminton, then he is not studying. The third one, the Azman is not studying, then his mother is angry. And the conclusion is, therefore, Azman's mother is angry. From this, we can assume Azman is playing badminton as P, he is studying as Q, and Azman's mother is angry as R. We can make argument from this. P to not Q to R, and the conclusion is R. Last example, if Sarah and Salsabila watch the television, then Salsabila will not hang out with her friends. If Sarah does not listen to music, then Salsabila will hang out with her friends. Sarah does not listen to music. The question is, A. Write the primary propositions using the variables P, Q, R, and S. B. Write all the hypotheses or premises using the variables in A. C. Use the rule of inference to prove the conclusion of the arguments. For question A, write the primary propositions using the variables P, Q, R, and S. We can separate the sentence. So P, Sarah watched the television. Q, Salsabila watched the television. R, Salsabila hang out with her friends. And S, Sarah listened to music. For question B, write all the hypotheses or premises using the variable in A. We can do it like the example 1 and 2 by changing it to arguments. P and Q to not R, not S to R, and not S. For the third question C, use the rule of inference to prove the conclusion of the arguments. So we can just use the arguments that we got in B. And we continue. Number 4, R, we get it from 2 and 3 using modus ponens. And then 5, not P and Q by using 1 and 4 modus tollens. And lastly 6, not P or not Q, we using number 5, De Morgan's law. So the conclusion is, Sarah or Salsabila did not watch television. Thank you.
A proof is the convincing argument expressed in the language of mathematics that a statement is true. Basically, all methods of proof rely on the forward-backward method. Therefore, this method will be the first attempt on the problem. The standard form of statement is if A, then B. There are 7 proof methods. For example, is forward, backward, construction, choose, specialization, contradiction, contrapositive, and induction. Definition and mathematical terminology. Number 1, M equal to Kn and divide to M denotes as N divide to M if M equal to Kn for some integers K, M, and N. Number 2, P greater than 1 prime if the only positive integers that divide P are 1 and P. Number 3, N equal to 2K when N is even. N integers N is N even if only if the remainder of dividing N by 2 is 0. Number 4, N equal to 2K plus 1 and integers N is odd if N only N equal to 2K plus 1 for some integers K. Number 5, R is rational if N only if R equal to P over Q where PQ element of Z and Q not equal to 0. Number 6, isosceles. A triangle is isosceles if 2 of its sides have equal length. Example 1. If x, y, and z are 3 consecutive even integer, then x squared plus y squared equal to z squared. A. X, y, and z are 3 consecutive even integer. B. X squared plus y squared equal to r squared. A1. Let x equal to 2p, y equal to 2p plus 2, z equal to 2p plus 4. A2. X squared plus y squared equal to 2p squared plus 2p plus 2 squared equal to 4p squared plus 4p squared plus 8p plus 4 equal to 8p squared plus 8p plus 4. R equal to 2p plus 4 square equal to 4p square plus 16p plus 16. A3. 8p square plus 8p plus 4 equal to 4p square plus 16p plus 16, and we got 4p square minus 8p minus 12. A4. P multiply which p square minus 2p minus 3 equal to 0. A5. P multiply which p plus 1 multiply which p minus 3 equal to 0. P equal to negative 1 and also p equal to 3. A6. X equal to 2 multiply with 3 equal to 6. Y equal to 2 multiply with 3 plus 2 equal to 8. Z equal to 2 multiply with 3 plus 4 equal to 10. 6 square plus 8 square equal to 36 plus 64 equal to 100 and equal to 10 square. A7. X square plus y square equal to z square. B is proven. Number 2. For any real number x and y, if x is rational and y is irrational, then x minus y is irrational. So we use contradiction method. A. X is rational and y is irrational. B. X minus y is irrational. A1 is not B. X minus y is rational. A2. X minus y equal to P over Q where PQ element of Z and Q not equal to 0. A3, let 3 equal to R over S, where RS element of Z and S not equal to 0. X over Y equal to P over Q. R over S minus Y equal to P over Q. A4, Y equal to R over S minus P over Q. Y equal to RQ minus PS over SQ equal to A over P, where A equal to RQ minus PS and B equal to SQ is not equal to 0. A5, Y is rational. A5 contradicts which B is proven.